Well, g'day flatties and globe defenders, it's Critical Think from Down Under. A couple of weeks ago I put out this video about Ranty wanting to see something loomed up. Soon after that, Ranty put out a response video, and this is my response to that. It's been a bit difficult for me to find the time to put this video together. I have a full-time job and other parts of life that keep me busy. But anyway, here we are. This is what Ranty thinks is a debunk, but I'll call it a Clayton's debunk. And if you're not Australian, you'll have to look that up on Wikipedia, what Clayton's means. And let's have a look at what Ranty says, and I'll pull it apart as usual. Here is the looming demo and Ranty's comments. I'll take myself out of the picture here. So he's going to pour some cool water, create a temperature difference in the air, maybe a little bit of moisture as well, I don't know. But the water runs down the driveway and cools a proportion of the driveway. And look at that, you can see something which was previously obscured by the curve. So it's loomed up. So something has been loomed up from behind an obstruction. Pretty simple. How can you get that wrong?
No, Critical Think. In actual fact, this is a perfect example of sinking.
Well, no, it's not sinking, and I'm going to show it's not. You know, Randy, you should take some of your own advice on these things. You just can't say it's sinking without proof.
Just saying that it's sinking is not proving it.
The other thing is, how does sinking happen? Is that perhaps refraction? Well, in order for something to move and be in a different position, that would be refraction, wouldn't it? And you flatties have a habit of denying refraction. You deny it when it suits you, and then you invoke it when it suits you. I think that's a part of Flat Earth rule number 32. Refraction can be used only in the case that it supports flat Earth. Any use of refraction by globers, for example looming or seeing further than the geometric horizon, must be vigorously denied. However, refraction is to be invoked when running into observations that cannot be explained by other pseudo-scientific means. Angular resolution, diffraction limit, etc. Let's carry on.
Dearie me, this is shocking. The clip top does not move a single pixel during the experiment. If this was looming, the entire clip would be loomed up, lifted up.
No. Looming, the definition of looming does not require that the entire picture is loomed. Refraction is not necessarily a linear transformation. In fact, closer to the surface you will get more refraction, and this will cause distortions. And no, the whole thing won't be lifted up. Some of it will be compressed. You're familiar with compression, aren't you? I've often heard flatties say about compression, so you must understand that compression is an artifact of nonlinear refraction near the surface.
Displaced from its original position. You could mark the top of it and see a movement upwards, denoting a change in position. We do not see that. In fact, the warm surface pulls the lower part of the image down, as shown in these still shots. The cooling of the surface simply removes the effect and restores the image to its original shape.
So, what Ranty is saying here is that the one on the right is the original shape. The one on the left has been pulled down by some mechanism which he calls sinking, but I think he means refraction causing it to appear to sink.
How on earth have you included this as proof of looming? This is shocking. This is not what I asked for, but...
Well, this is indeed what you asked for, and I'll go over again why it's proof of looming in a minute.
Thank you for showing this test, as it is a great proof of sinking, things disappearing from the bottom up due to refraction.
So, things disappearing from the bottom up due to refraction. So, refraction's okay when things can disappear from the bottom up, but refraction's not okay when things are loomed up. Right. So I've managed to find a frame out of the original video that shows the object in its entirety clear of the curved driveway, so you can see the original shape of the object. Now we can compare this original shape of the object with these two images. I've got this blink test here. You know I'm a big fan of blink tests. But the one on the left is sinking according to Ranty, but you should listen to yourself on that, Ranty.
Just saying that it's sinking is not proving it.
Now we'll do the blink test on the one on the left, which is supposedly sinking. So blink in and out, you can see the one on the left matches exactly with the original object. Then we move over to the one on the right and we'll blink test that, and you can see blink test, it's compressed and loomed up. You can see here that this peg is the normal size, this one is thinner, it's compressed, and this is moved up. Well, Ranty, that one on the left is not sinking, and that one on the right is looming, so you're well and truly busted on this one. That is definitely a demonstration of something loomed up over a curve, and you say that's not what you asked for.
Show me a demonstration of somebody going out of the way to try and prove that something has been loomed up.
So by your logic then, I suppose you'll think that this car is sunk below the road because of sinking, and then, well, I know what you're going to say about this one. Can you see any signs of refraction there? Just like in the last demonstration, there was no sign of any sinking. There's no sign of any sinking here. If there was refraction going on that caused that ship to sink that far, do you think that we'd notice it? Of course we would. So no, that's not sinking. So let's hear again what you asked for.
Show me a demonstration of somebody going out of the way to try and prove that something has been loomed up.
And we showed you this. This demonstration, I'm not going to go into your so-called debunk of that, and I'm not going to go into your so-called debunk of that either. These were demonstrations that showed that looming is possible, and this is how it happens with refraction. It's not meant to be a real-world over-the-ocean scenario. It's a demonstration of looming, which is what you asked for. So, now that we've provided what you asked for, I see that you've invoked Flat Earth Rule number 56. Be careful when issuing challenges to Globers that you make the challenge impossible to achieve. They are an ingenious lot and may surprise you by actually meeting your challenge. Should you run into this unfortunate situation, please refer to Flat Earth Rule number 5, moving the goalposts. So let's have a look at the moved goalposts. I'll take myself out of the picture for this bit. Can any Glober or Flat Earther provide me proof of looming? Well, they have, and we'll get to that in a little while. But first, yes, we have done that, and I will show you the proof again, but let's carry on. You want to see a building or an object. Well, why do you say building? I think I know, but if you say building or an object, then that could be anything. It could be a coin in a glass, or it could be something sitting on a driveway somewhere. So, you know, really, you're not tightening up that requirement very much. And then you've now inserted beyond Earth curve. Well, this is very difficult because flat earthers say that there is no Earth curve. So it's pretty much impossible to demonstrate to a flat earther because they'll just deny Earth curve. The other thing is there's no requirement in looming for an object to be loomed up in its entirety. That's just something you put in to make it more impossible. And the same with being able to see the target without any distortion. As we've shown before, when you've got something loomed up, there's high likelihood of distortion. So this without any distortion requirement is unrealistic and probably impossible. And it's not a hologram projection. That's not the definition of hologram. If that were the case, then every picture you've taken with your camera would be a holographic projection. So none of this is necessary. We can see something lifted up from beyond a curve. That's been done. From beyond Earth curve, well, let's have a look at this. Here is an example of something loomed up beyond Earth curve. You can see that the far drilling platform is over the Earth curve, and on the left you can see that it's lifted up. Now I say this because the Earth is definitely curved. It's been measured. It's well-known scientific fact. So on the left you can see there's some distortion, and that platform further away is lifted up beyond Earth curve. And we have your own example. I don't know why you're asking us to provide this when you've provided a very good example yourself. Now, who's to say that there's no distortion in that one? You know, you can see distortion in the upper image. There's not enough information to be able to tell if there's any distortion in the lower one. But the Earth is curved, and that's looming up over the Earth curve. I've gone out and I've done here what is possibly groundbreaking research in the area of refraction. Now, I don't think anybody has done this before. I've never seen it before anyway. This is unique. This is a day of high refraction, and getting a few of those days lately. This ship, this picture is taken from a height of 15 meters. And just by looking at the proportions of the ship, there's already some refraction going on there. But then I take another picture from lower down. This second picture, I haven't showed it yet, but this second picture I will overlay is taken from right a few inches above the water. And I'll run this a little bit slower. Right, let's bring this into the middle. And we'll blink test this one right on the water, a few inches above the water, and from 15 meters high. Now, the thing to note here is that the sea level appears to rise in relation to the cranes that are higher out of the water, and they wouldn't be subject to the same amount of refraction as right over the water. So there is compression there. Now, we know that there's Earth curve there, so this is actually loomed up over the curve. And even if you're not going to believe for religious reasons that there is a curve, then you have some explaining to do. So you need to explain how this can happen when there is no curve. That's definitely compressed. So you're going to have to work out how does that compression happen. So you're going to have to admit that there's refraction. Refraction that causes light to bend down, causing that to rise up, and causing that compression. If you admit that there is that kind of compression and that kind of light bending, then you've destroyed every flat Earth argument that's ever gone on about the geometric horizon and the complete total lack of refraction on any of the observations that supposedly prove a flat Earth. You always say that the observations don't match a geometric globe. Yes, that's right. We've always said that they don't because of refraction. So you're either going to have to admit that refraction here exists in this demonstration, or you're going to have to come up with something else. Who knows what? I'm sure you'll be creative and come up with some bollocks story. A sort of a rough explanation of how this works on a curved surface. As you go down in elevation, this is the person looking over here. As you go down in elevation, the curve gets in the way. Now, in those images I just showed you, there's also refraction and causes the bottom of the ship to loom up. And that's why you see the bottom of the ship. Now, on a flat surface, you can see there's no obstruction ever. No matter how low you are, there's no obstruction to the bottom of the ship. But then you have to ask yourself, how does the water rise and how does the ship get compressed? So I'd like to see some diagrams from flat earthers that show how that can happen. Looming is a thing, get over it, and I've shown that your sinking was not a thing. So where you have photos that you think you can see too far, further than the geometric horizon, you need to prove that it's not looming. The Earth is curved, it's a scientific fact. If you want to say that that's not looming, then you need to prove that the Earth has no geometric curve, that it's geometrically flat, not by looking but by measuring. And then you might have something.